So the basic unit of polypeptides is the amino acid. The amino acid consists of an amine group, that NH2, and a carboxylic acid group, that COOH, hence amino acid. That's where the name comes from, amino acid. They've got a central carbon. That carbon is attached to a hydrogen, and then it's also attached to something else. And those something else are described as R groups. And so the way different amino acids differ from one another is in terms of what this R group is. And there's 20 naturally translated amino acids. You can also modify amino acids after they've been put into proteins or polypeptides. But there's 20 naturally translated amino acids. And these amino acids differ in terms of the R group attached to this central carbon. Now, when you're linking together the amino acids to make a polypeptide, what you do is you form a peptide bond. And this is an example of dehydration synthesis. So what's happening is you're taking out that OH, and you're taking out that H, removing a water molecule, dehydration synthesis, and you're left with a bond. And that's the bond there, and that's called a peptide bond. And those peptide bonds happen to be interesting bonds because this is called a double bond here. And due to something known as resonance, the actual peptide bond, rather than just being a single bond, actually acquires some of these double bond tendencies, which is what is shown right here. And that actually is important because a single bond freely spins. It's like a wheel on an axle. But a double bond doesn't spin. It's locked in place. It's almost like having a wheel on an axle with a brake engaged. And when you have what's known as partial double bonds, you have an impediment to spinning. And what this does is when you link together long chains of amino acids, rather than the chain being just all floppy and can spin around, there's some structure to that chain. And as a consequence, the proteins that are made up of these chains have a stiffness to them that is greater than would be the case if, in fact, that bond was simply a fully rotatable single bond. And that's why I call the polypeptide spaghetti with attitude. So this would be the spaghetti after it's cooked, or al dente, or what have you. And the amino acid chains, the polypeptides, are more than just floppy noodles. They in and of themselves have some structure. Additional structure comes when the R groups and also the various other components of the amino acids start interacting with one another.